everyone, it's your SI leader Noora here today to work out a quick hydrohalogenation problem. And I'm going to use this problem to discuss carbocation stability and regioselectivity. So right here we have an alkene species, and we're going to react this alkene species with our hydrogen bromide. Our double bond is going to function as a nucleophile and pick up this hydrogen atom. This electron region of the covalent bond is going to be shot off onto that bromine, producing a bromide anion. And from this, you're going to get two carbocation intermediates. So let me draw those out for you. For the first intermediate, we can have this hydrogen addition at this area of our double bond, this side of our double bond, producing this carbocation. And for the second option, we add our hydrogen at this point, producing this carbocation intermediate. So now this brings us to the idea of Markovnikov Regioselectivity. And Markovnikov Regioselectivity basically states that your reaction is going to proceed through the most stable carbocation intermediate. Now, which one of these two is the most stable or more stable carbocation? And this brings us to the idea of hyperconjugation. So I have it all written up here, but a tertiary carbocation is going to be more stable than a secondary carbocation, which is going to be more stable than a primary or just a positive charge on a methyl. So looking at this carbocation intermediate first, you have your carbon attached to two other carbons. So this would be a secondary carbocation versus this carbocation, which is, again, a carbon attached to 1, 2, 3 other neighboring carbons, producing a tertiary carbocation. Now, why is it that a tertiary carbocation is more stable than a secondary, as I've outlined up here? And this brings us to the idea of hyperconjugation. So hyperconjugation is the mechanism whereby neighboring alkyl groups, neighboring CC or CH bonds, can stabilize the empty p orbital on this carbocation by sharing some of their electron density with it. So the more neighboring CC or CH double bonds you have, the more hyperconjugated your system is and the more stable your carbocation is. So this is going to be your more hyperconjugated and therefore more stable intermediate. So just working on completing our reaction here, we had our bromide anion. It's going to attack this electron deficient center, again, your carbocation center, producing our products, which I'll draw out here for you. And in this case, you have that versus this. And because this was our more stable carbocation intermediate, we know that this is going to be our more major product, our most major product of this reaction. So this is going to be our major product. Again, because of this idea of Markovnikov addition across your double bond.